So this is the main derivation. So this we derive from the force diagram. We resolve lift and drag in the thrust equation, and we know lift and drag in terms of basic equations. Half rho v square s cl, substitute here. CD d also half rho v square s cd, substitute here. Then this half rho v square cdr and all common term, you take it outside. Remaining you will get cl cos phi minus cd sin phi. Okay. So this equation we are writing from the force diagram. Substitute dl dd in the basic terms. Then take common terms of rho vr squared cdr. Remaining is cl cos phi cd sin phi. So instead of this big term cl cos phi cd sin phi, they are writing this as simply t. Okay. So this term straight away we are taking, and instead of this cl cos phi minus cd sin phi, they are taking t. So if this dr, if you take to the left hand side, we will get thrust grading. This is thrust grading, and this is for only one blade. Okay. And if there are number of blades, then the same equation we have to multiply with a b. Okay, for number of blades. So this is the final term, thrust grading for the small cut section. We are including all the blades. And the same equation we are writing in terms of sigma also, that is solidity ratio is BC divided by 2 pi r. So we have B term, 2 term, C term and all. So we can rearrange this in terms of sigma also. So we are getting this final term. Is that clear? So first thrust equation, then substitute dl dd, simplify. Okay, this is thrust grading, and this is, if you multiply with a b, this is for complete propeller. So this is final equation, or we can write in terms of solidity ratio also, pi r sigma. Okay, solidity ratio also, it will be a given parameter. When you are buying the propeller, they will give this value also, what is the solidity ratio. So this is thrust grading, we found it. Next we are going to find the torque grading. And this is the simplification step. Here I told, right, the CL cos phi minus CD sin phi, they are taking us T. So this they simplified also a little bit, but in the exam, if you want, you can skip also this step. But here I explained. So CL cos phi minus CD sin phi. First they are taking CL outside. So you will get CD by CL. And instead of this CD by CL, I can substitute tan gamma. Okay. DL, DD, DR, gamma. Okay. So tan gamma is CD by CL. So instead of this, we are writing tan gamma. Then instead of this tan gamma, I am writing this sin gamma by cos gamma. Then I am taking 1 by cos gamma outside. Okay. So 1 by cos gamma is secant gamma. So 1 by cos gamma, you take it outside, but I can write it as secant gamma. So remaining you will get cos phi cos gamma minus sin phi sin gamma. Okay. So secant gamma is 1. So this time they cancel. Remaining it is like cos A cos B minus sin A sin B. They are writing as cos A plus B. So that term they are taking as T. But again it is same only. Whether you take this term as T and this as T, it is both same only. In book they follow this procedure. Okay. So in the exam, for example, offline mode means this step just for understanding. You can skip. Straight away you can mention CL cos phi minus CD sin phi is equal to T. Okay. So same procedure you can apply for the torque force also. So this equation, substitute DL and DD, again simplify in the same fashion. You will get this equation, dq by dr is equal to, in terms of sigma and q. Again q is, here also you will get some CLCD term. Instead of that they are taking q. Okay, this you can refer the notes, almost same procedure, so I skipped it. So this we derive. This same procedure we have to follow. Okay, instead of T here we are taking Q. So we found thrust grading and torque grading. Then we are finding the efficiency. Power output by power input. Power output is the thrust produced by the propeller and the free stream velocity. And power input is that is due to the torque of the propeller. So we are writing the same fashion as so angular velocity into the torque force. Okay, so this is free stream velocity into thrust. This is angular velocity of the blade into the torque force. So RR get cancelled. So remaining Q into dQ. So just now we found dt dq values, substitute, or we can multiply dr on both sides. So straight away we can substitute dt by dr here, dq by dr here, cancel, we will get this term v1t divided by q or sigma.